This is Sean O'Neill, CA1 Semester 2 of second year, and this is the Make Your Own Array CA. This is the array.h file, and as you can see it's got its inclusion guards in, and then I've hash defined a CRT secure no deprecate to suppress the error from fopen when you're writing out to file, because Microsoft have deprecated it to apparently in an attempt to increase security, but it doesn't work as fluidly with other platforms, so I decided to just use fopen as opposed to fopen s. I have the rest of my includes just below that, then the IO stream and the algorithm, and then the F stream. I then have the start of my template class, which will take in any data type, but I've only ever tested it for ints as I ran out of time. The name of the class is array. My member variables are private, and that's the data type that makes the array. The size, the grow size, and the number of elements. My public attributes are the constructor and destructor, the resize function, the overriding of the operator, and the conversion, so you can pass it in to functions, the push function, the reset function, the print function, the ordered remove function, the pop function, the search function, clear, size, set size, write ordered, and read unordered. The constructor and destructor are just pretty plain. They're self-explanatory, really. The resize function, just when you call it, you have to put in the new size that you want, the size that you want the new array to be, and you then make a pointer to the new array and make the new array of the data type that you want to pass in of the new size. You then set all of them to be 0, all the values of the new array, and then if that works, then it should just carry on. If it doesn't, it'll throw an error. This is where you determine if you're making the array bigger or smaller than the old one, and then you copy all the elements over. You set the size of the new array to match the number of elements. You delete the old array using square brackets so as to delete every element so that you don't get a memory leak. And then you change your pointers, so you change the pointer from the old array to the new array, so calling marray will now just point to new array instead. And then you set the new array to 0, so that's the old pointer is now a null pointer. The override operator and the conversion operator are just so that you can have more functionality with this array. So it will act a lot more like one of the standard library vectors or arrays. You can pass it into functions and call the square bracket operator to find an item at the index of. And the push function, which inserts a new element in ascending order, has a complexity of order n, because depending on how many objects you have, you might have to resize the entire array. So for example, if you have 5 objects in it, and the first object is a 1, or we'll say the first object is a 5, and then after that it's 6, 7, 8, 9. Then if you try to add in a 4, you're going to have to copy it's going to try and put it into the first spot, which is correct, but then you have to copy every subsequent element up to the index above it. So you can potentially reorder the entire array during this function. So it's not bad, order n, but it's also not great. it could be a lot better, but it also could be quite worse. And in it, it checks if the number of elements is equal to the size. So if the number of elements is equal to the size of the array, then that means it's full, and you resize it by the grow size that you specified earlier. Otherwise, you perform the push function, which is just you loop through to see to compare them, and as soon as the object you're trying to pass in is less than or equal to the object that is in the position, you copy that position and then copy every subsequent position upwards. So you open up a spot at that index and then you copy the new item in. The reset function just sets all the elements to 0. It's not one of the functions that's callable from the menu, but it helped me out using it in the code. It's a complexity of order n because, again, you have to go through every object in the array, every element in the array, and set it to 0. So it relies on the amount of objects, or elements you have in the array. The print function prints the array. Again, that's a complexity order n because you have to print everything, so you have to loop through the entire array and print out each index. The remove function, it's an ordered remove, so it keeps the order of the array, which once again is a complexity of order n because worst case scenario is you remove the object at the first element, the element at the first index, and then you have to copy everything else down. The pop function just removes the last index, the last element of the array, and so it's a complexity of order 1 because no matter the size of your array, you're just removing one element from the very end, so you don't have to copy anything down either. The search function searches for a value and returns the index. So if you're looking for a 9 in an array, just put in the value 9, that gets passed in, it searches through the array for a 9, once it finds a 9 it returns the index that that value is at. It's got an order of n, it's a complexity of order n because you might have to loop through everything in the array potentially. If it's the very last element, you'll have to loop through the entire array. The clear function just clears all the values out of the array. The way I did it was I set m size to 1 because setting m size to 0 and then attempting to create a new array was throwing a stack heap corruption error. So I just set m size to 1 and then called my reset function, which set everything in the array, which is that one element, to 0. So for all intents and purposes it empties the array, but there's still one element that's a 0 in it. But it just allows you to carry on if you want to clear the array and then make a new one right after it stops that corruption error that I was getting. It's a complexity of order 1 because it doesn't matter how many elements you have in the array, you're just immediately setting the size to 1 and resetting it. Well, changing that one value to 0. The size is just a getter to the size of the array, and the set size is just a setter to the size of the array. The write file function is the exact same as we wrote in class, except for a few minor changes that aren't really worth noting. Just, it's a regular file output. It will input output. The fact that it opens the file, it writes in binary, that's what the WB is for. Checks to make sure you could write. You write out the array, then you close the file, and if you don't get what you expect, you return a false, because that means that there was some error with the write, and then the read is very similar, except you're reading in instead of writing out. My main app just is an interface to allow the user to use the array. It's very similar to any other driver class you might have seen. I just have my includes here. My define of the CRT debug map alloc is to check for memory leaks. I've got my usings and I open my main. And then this part here says that if you're debugging, then throw a memory leak error if you have one. So if you're not debugging, then it should stay quiet, which is sometimes helpful if you have a memory leak and you want to publish your code, which is not recommended, I know. I have my enum for my switch statement here, which makes it a bit more readable. Then I have my boolean, which just keeps the while loop going, so it keeps the program executing until you want it to stop, so until you call exit. I create my array outside of the switch statement because creating it in the switch statement was giving me scope errors, well, scoping problems. And then I set the size initially to 10, and I set all of the elements to 0 using my reset function. And then I enter my while loop. I want to print out every time, just to make it, to give the user a bit more feedback. I printed out your current array, and then it prints out the entire array that you have already, which I know could get very cumbersome depending on the amount of elements that you have. But I found that having nothing displayed on the screen was kind of confusing and even a bit disorientating, because you didn't know whether or not your changes were happening. Whereas with this, you can see them instantaneously, or almost instantaneously. I just come in and I print my menu, which welcomes the user and gives you all your options. And then I take the choice and throw that into the switch statement, which then, using the enum, just goes through the different options. The different options are up here: create, add, remove, pop, clear, search, write, read, and exit. And they're numbered 1 through 9, respectively. The create menu option just asks what size you'd like the array to be, and then it just simulates a create because of the scoping errors that I was having. I didn't have enough time to solve them, so it just takes the array that was created earlier outside of the scope and resizes it to whatever size the user would like it to be. The add option just asks whether you'd like to add an element in order, change the resize amount, or exit. If you add an element in order, then it just asks what element you'd like to add, so you enter in your number and then it pushes it in order. Changing the grow size just changes the grow size, so if the array fills up, it'll grow by a user defined amount. And the exit just exits back out to the main menu. The remove function is the index remove, the order remove, so that will allow you to, it first of all asks what element do you want to remove. Well, that's all it asks, sorry, and it removes the element at the index that you give. And then the pop function just knocks it off the end, so it doesn't really need to ask for anything. Just once you hit pop on the menu, it'll automatically pop it off. The clear function is the same. Once you hit it from the menu, it'll automatically clear the array, so it just reduces it to one element and changes that to a 0. The search function asks what number you want to search for, and then it loops through the array looking for that number. If it finds the number, then it will tell you that the number occurred at position, and then it prints out the position that it occurred at. The write option writes out to the ordered.txt file, and the read function reads in from unordered.txt. The exit function just exits the entire program and quits the while loop. I'm just going to attempt a quick demo of my code now. I already have my array created and everything, so I'll just add an element. So I add a 1, and it shows here your current array that I've added a 1. And then I'll pop and then exit.